Good morning, ma'am. Good morning, classmate. We are going to report about circles. So, first, let's find what is the objectives of this lesson. First, we can define and identify the basic terms about circles. Second, we can solve problems on lengths related to common tangents to a circle. Third, we can define and apply arc measure and arc addition postulate. Fourth is we can state and apply the theorems regarding tangents, the chord diameter theorems, inscribed angle theorem, and the theorems regarding the measure of angles formed by chords, tangents, and secant. I'm Elvin Kagampang and I am going to report the basic information of a circle. So, we have here the image, which is the given circle. The center is O. So, first, we have here radius. The radius here is the line OA, OJ, OD, and OC. Radius is a line segment between the center and a point on the and a point on the circle. So, radius in a circle are congruent of the same length. So, second is chord, the line EB and CJ. A line segment, chord is a line segment in the interior or the circle with both endpoints on the circle. We can see there that the point of EB and CJ is the endpoint of the circle. Third is diameter, which is the CJ. A diameter is the longest possible chord. We can see in the image that EB line is not at the center and it is not the longest possible chord. So we only have one possible chord, which is CJ, and that is the diameter. Next, we have a secant. The line AB and FE is a secant. A secant is a line passing through 2 points on the circle. A secant forms of a chord in the interior of the circle. Next is tangent. We have here the AH, GH, and FG. Tangent is a line touching or intersecting a circle at one point without entering the interior of the circle. So they are intersecting, but they are not in the interior of the circle. So that is tangent. Next is point of tangency. So point A, point J, and point D is the point of tangency because that point in a circle which tangents are touches and intersect a circle. So next we have arc. The arc AJ, JB, BD, JJ, JG, and AGB, and so on. There are so many arc in this circle. Arc is a part of a circle's circumference. If we will add all the arcs, it will result as the circumference of the circle. So next, the minor arc. We have in this picture we have minor arc AJ, JB, BD, and so on. There's so many minor arcs. Minor arcs are whose length is less than the length of semicircle. So we know that semicircle is less than semicircle is 180 degrees. So this is less than 180 degree. It means it is a minor arc. So major arc is AJD, BDA, CAB, and so on. Major arc is any arc whose length is greater than the length of a semicircle. So, with a corresponding central angle greater than 180 degree. Major arc are usually named using 3 letters to distinguish them from minor arcs. So, next we have semicircle. The arc CAJ and CDJ are semicircles because they have the exact half of the circumference. So they have the corresponding central angle equal to 180 degree. So next, these are the common problems in tangent to two circles. We need to prove that a transverse common tangent drawn to circles divides the line joining their centers into ratio of the radii. Arc measures. We have already the addition postulate formula. So the addition postulate formula is the measure of AD plus measure of DB is equivalent to measure of ADB. So what is arc measure? Arc measure in a circle is the degree of measure of an arc is equal to the measure of the central angle that intercepts the arc. So example, we need to find the measure indicated arcs in a circle, which is EB is the diameter. So this image is our figure to answer this arc addition postulate problem. So we need to find the measure of if ED. So if E plus MAD is equivalent to M if AD. So addition, so we need to find the exact value of that variable, and then we need to add them. So the FE is we just need to minus the 180 because FE is part of the semicircle, so 180 minus 60 is equal to 120, and then the AD is part of the other side of semicircle, and then we just need to add the 52 and then the right angle there, which is 90. So 52 plus 90, and then measurement of ED is equal to 38. So 120 plus 38 equals 158. So the B and C there is the same process. So we just need to find the measurement and then add them all. So next, this chord diameter is being reported by Ms. Lumangco.
Chord diameter theorem is all about the chords and diameters in a circle and their converses. If a diameter of a circle bisects a chord, then it must be perpendicular to the chord. If a diameter of a circle is perpendicular to a chord, then it bisects the chord. If two chords are congruent, then the center is equidistant from the two chords. There are 4 theorems of the chords. First theorem is, in the same circle or congruent circles, minor arcs are congruent if and only if their corresponding chords are congruent. Theorem number 2. The perpendicular bisector of a chord is also a diameter. If segment AD is perpendicular to segment BD is congruent to segment DC, then segment EF is a diameter. For the theorem number 3, if a diameter is perpendicular to a chord, then diameter bisects the chord and its corresponding arc. Chord theorem number 4. In the same circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. The shortest distance from any point to a line is the perpendicular line between them. If segment FE is equal to segment EG and segment EF is perpendicular to segment EG, then segment AB and segment CD are equidistant to the center and segment AB is congruent to segment CD. Example number 1. Find the value of X and Y. The diameter is a perpendicular to the chord, which means it bisects the chord and the arc. Set up equations for X and Y. Open and close parenthesis, 3x minus 4 degree is equal to open and close parenthesis 5x minus 18 degree. So first we need to arrange there's the same variable. Positive 2 is positive 7. Y is equal to positive 3.
Here the inscribed angle theorem. So what is an inscribed angle theorem? An inscribed angle theorem is that each degree is half of the central angle, or the 2a degree. So we can see here an image. This is called angle of center theorem, and the angle here is a degree is always the same, no matter where it is on the same arc between the endpoints. For example, for inscribed angle theorem, just look at your module. The theorem of angles will be reported by Mr. Palarca.
Good afternoon, everyone. Our lesson for today is about the theorems in measuring the angles on circle, inside and outside circle. First, the theorem of angle on a circle. It is the measure of an angle formed by a chord and a tangent that intersect on the circle is half the measure of the intercepted arc shown as shown in the figure. Therefore, any angle with each vertex on a circle will be half measure of the intercepted arc. For example, find the measure of an angle BED with the given values as shown on the figure. We are going to use the formula using the theorem 9 to 11. So, here's the solution. The measure of an angle BD is 1/2 of the measure of the angle EB, which is 124 degrees. Therefore, the measure of angle BD is 62 degrees. Please see the solution on the right side of the slide. Next, angle inside a circle. It is a measure of an angle formed by two chords that intersect inside circle in the average of measure of the intercepted arc. Find x. The intercepted arcs for x are 129 degrees and 71. So, x is equals to the sum of 129 plus 71 over 2 equals 200 degrees over 2 and equals 100. So therefore the x is 100 degrees. At angle outside a circle. A measure of an angle formed by two tangents or a secant. A tangent drawn from a point outside the circle is equal to half and the difference of the measure of the intercepted arcs. For example, find x. So then example number 2. 40 degrees is not the intercepted arc. Be careful. The intercepted arc is 120 degrees or 360 degrees minus 200 minus 40. Therefore, x is equals to the sum of 200 degrees minus 120 degrees over 2 and 80 degrees over 2 and x is 40 degrees. So, that's all.